Hi for everyone. My name is İdil Tatar, and I would like to talk about auditory localization performance based on various sensor training modalities and material properties. This research was done in Computational Neuroscience and Visual Perception Laboratory in Yeditepe University. Sound localization is one of the fundamental abilities of humans for interacting the environment, and audiovisual multisensory integration serves important cues to localize a sound source. According to spatial principle, a spatially congruent visual and auditory information increases sound localization performance. However, according to inversive effectiveness, stimulus intensity and task difficulties are two main domains that modulate this performance. Therefore, one sensory modality can either enhances or suppresses the other modality. We wanted to investigate the effects of audiovisual integration on auditory localization performance on everyday materials, and to find out which sensory priming is most efficient for impact sound localization. We expected that either based on enhancement effect, audiovisual multisensory cues reveal better localization performance, or based on suppression effect, visual and audio unimodal sensory cues reveal better localization performance. We included 34 participants in our study with opportunity sampling and divided into 4 different conditions with between subject design. Audio and visual information of stimuli were spatially congruent, and stimuli presentation was in a pseudo-randomized order for the main task. Our stimuli materials were ceramic plate, glass jar, leather drum, rubber rope, metal knife, and wooden rod. These materials were marked in 4 or 5 different points with equal distances. The tapping sounds and images of these materials were recorded for stimuli presentation. Based on condition type, participants were presented with either visual, auditory, or audiovisual priming phase. No prime condition had no priming phase. After the priming, they were presented only auditory information of the impact sounds, and then, based on the condition type, they were presented with an either real or illustrated image to decide which mark point was associated with the impact sound they heard. Here is an example of audiovisual prime condition test paradigm. First, priming phase for 4 seconds duration. Then, fixation mark for 2 seconds duration. And then for the main task, auditory stimuli for 3 seconds duration per individual impact sounds. And response screen for 5 seconds duration. Then next auditory stimuli comes. Individual impact sounds were presented individually for 4 times, each in a pseudo-randomized order. In our findings, overall localization errors were higher than overall localization accuracy, so we analyzed both. Rejecting the first hypothesis, audiovisual prime did not demonstrate the highest accuracy across conditions. On the other hand, localization errors in audio and audiovisual prime conditions were found to be significantly lower than in no prime condition. Based on material type, only metal knife demonstrated significant difference in localization errors. The lowest amount of localization errors for metal knife was observed in audiovisual prime condition. It was found that the stiffer and the more linearly aligned objects such as wooden rod and metal knife, there was a relatively more error response. Enhancement for audiovisual integration was observed only for metal knife. This supports inversive effectiveness. Overall, metal knife demonstrated the lowest accuracy. So, in support with inversive effectiveness, multisensory integration becomes an advantage when task is difficult or stimuli intensity is low. Unimodal audio and visual prime did not demonstrate higher localization performance across conditions. However, localization error in visual prime was slightly lower than in no-prime condition. So, although the task was auditory-based, vision played an enhancement effect in performance. Thank you for listening. Here is our contact information for further questions.